Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak Nemani and this is Daily Quant with Deepak. Hi all, welcome back to day 62 of 100 days to CAT Quant series. In this video, we will be discussing 5 questions from P&C and probability. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video helpful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to this channel. In case if you want to attempt these 5 questions in the form of a test, you can sign up in our portal, the gurukul.org.in. Right, once you sign up, you will get access to a course called 100 days race to CAT, in which there will be 3 sections: quant, VRC and LRDI. We'll be uploading 100 tests in each section, so that if you are a serious CAT 2025 aspirant, you cannot afford missing these tests. Now these questions are handpicked by us, right? And these are absolutely for free. So without any further delay, let's get started with the first question. Now coming to the first question, S is a set of 4-digit numbers formed using the digits 5, 6, 7 and 8, using each digit only once. M is a subset of S that contains numbers whose tens place digit is a prime number. What is the sum of all the numbers in M? So M is a subset of the 4-digit numbers formed by the digits 5, 6, 7, 8, where the tens place should be a prime number, or this should be a prime number, right? And the digits must be 5, 6, 7, 8 without repetition. So what are the prime numbers? 5 and 7. So tens digit should be either 5 or 7, right? Now let's find the sum of all the numbers having 5 in tens place. Then we'll repeat the same process for 7, right? Now let me fix tens place with 5, right? So we are left with 8, 6 and 7. Now these digits will come in thousands place, hundreds place and units place, right? Not in tens place, right? Now let us find the number of numbers in which 8 will be in thousands place. There are two numbers, 8756 and 8657, right? So we'll be adding these two. We'll be adding only the values in the thousands place, right? So if I place 8 in the thousands place, you have two numbers, right? In these two numbers, you will be having 8 in thousands place, so they add up to 2 into 8,000, 16,000. Number we are adding just the value of the places of these digits. Now similarly, when I have 7 here, then also you'll be having two numbers. So you have two numbers with 7 in thousands place. So the value of the thousands place would be 2 into 7,000. Now similarly, you'll be having 6. 2 into 6,000 done. So we have added all the values in the thousands place. Now similarly coming to hundreds place. Right. Now let's shift 8 to here. How many numbers are there? Two numbers. Right. 7,000 and 6,000. Right. And those, the values in the thousands place we have already considered here. Now let's add the values in the hundreds place. Right. So 800 into how many such numbers? 2. Now similarly, if I replace 8 with 7, we'll be having 700 into 2 and then 600 into 2. Right. Now let's come to the tens place later. Again, after placing 8 in thousands place, hundreds place, now let's put in units place. Right. Then you will be having 2 into 8. Then similarly 2 into 7, 2 into 6. Now this would be the sum of all the numbers, and sorry, thousands place in all the numbers, hundreds place in all the numbers, and units place in all the numbers, right? So I can take first 8,000 common. If I take 8,000 common, you will be having two, sorry, let me take what should I take common? 2 common. Then what do we have? 8,000 plus 800 plus 8, 8808, plus if I take 2 common, then 7707 and 2 common, 6606. Right? Now these are the sum of the values in thousands place, hundreds place and units place. Now how many numbers are there in total when 5 is in tens place? Now if you have 5 here, right? Now we are left with 3 more digits, 6, 7 and 8, and we have to arrange them in these 3 places. that could be done in 3 factorial base, right? So in these 3 factorial numbers, you have 5 in tens place. So what will be the value of tens place in all these 6 numbers? 5 into 10, right? Now this would be the sum of all the 4-digit numbers formed by the digits 8, 5, 6 and 7, such that 5 is in tens place. Now similarly, let us replace 5 with 7. Then what will we have? Right. Now we will be having 2 into 8808 plus 2 into 6606 plus 2 into, instead of 7707, you will be having 5505 plus, sorry, this is not into, plus, we have 6 numbers where 7 was in tens place. Done. Right. Now, if I take common 8808 into 4, that would be 32,000 plus 3,200 plus 32 plus 6606 into 4, 24,000 plus 2,400 plus 24 plus 2 into 7,707, 14,000 plus 1,400 plus 14 plus 2 into 5505, 10,000 plus 1,000 plus 10 plus 6 into 5, 30, 30 into 10, 300 and 6 into 7, 42, 42 plus 10, 42 into 10, 420, 300 plus 420, 720. Now let's add this, 24,000 plus 14,000, 38,000, 38,000 plus 32,000, 72,000, sorry, 70,000, 70,000 plus 10,000, 80,000. So 80,000 plus same 3,200 plus 2,400 plus 1,400 plus 1,000. That would be 8,000 plus 32 or 24 plus 14. That would be 38, 38, 48, 48 plus 32, 80, 80 plus 720, 800. So this should be 88,800 should be the answer to this question. Now coming to the second question, P persons are sitting at the corners of a P-sided table. They are asked to pass around a bag of coins. There are 2 rules to be followed. A person cannot pass the bag to his neighbor. There should be exactly 1 pass between all possible pairs of persons. Each time the bag is handed over, a bell rings. If after all the possible transactions are over, the bell has rung for 90 times, we are asked to find the number of people. Now, let me consider that there are P people. Let this person be, let us say X, right? Now, he won't be able to pass the bag to this person and this person who are adjacent to him, right? So, he will be able to pass the bag to this person, and remaining all others. Now, what I'll do is, I'll join all these points using straight lines. Now what is this? This is nothing but p-sided polygon. And what are these lines? These are nothing but the diagonals, right? So indirectly, we are given with the number of diagonals in a p-sided polygon, 90. Why 90? Because every time there is a pass, like, so every time a line is drawn, the bell will ring, right? So the bell has rung for 90 times. That means there are 90 diagonals. So p into p minus 3 by 2. Now this is the formula to calculate the number of diagonals in a p-sided polygon, right? So if a polygon has p sides, the number of diagonals would be p into p minus 3 by 2. This is given to be 90. So p into p minus 3 should be equal to 180, right? Now we need to write 180 as a product of 2 numbers such that the difference is 3, right? P and p minus 3, difference is 3, right? So what is that number? Or you can just verify through options, right? So if p is 15, P minus 3, 12. 15 into 12, 180. Yes, so the value of P has to be 50. Now coming to the third question. Suppose set A is a set of 5 natural numbers as follows: 2, 5, 9, 13 and 14. 2, 5, 9, 13 and 14. Now n1 is equal to number of circular permutations of all the numbers from set A such that the adjacent numbers are relatively prime. So there should not be any common factor between any two adjacent numbers. Now if you observe 2, 5, 9, 13 and 14, out of these 5, there is a common factor 2 for only these two numbers, 2 and 14. So that tells me that 2 and 14 should not be adjacent to each other, right? So we need to ensure that 2 and 14 should not be adjacent to each other while finding n1. Now what is n2? Number of linear permutations of all the numbers from set A such that the adjacent numbers are relatively prime. Now same condition, but in the case of n1, we are considering circular permutations, whereas n2 linear permutations. Right. Now coming to n1, we need to find the number of possibilities in which 2 and 14 are not together when all these 5 numbers are placed around a circle, right? So to find the value of n1, what I'll do is I'll find the total number of ways and I'll subtract the number of ways in which 2 and 14 are together, right? So that will give us the number of cases in which 2 and 14 are not together very easily, right? So what are the total number of ways? 1, 2, 3, 4, 5. You have 5 items around a circular table, 4 factorial. Right. Now, let us find the number of ways in which 2 and 14 are together. Right. So, to find that, I'll be considering 2 and 14 to be 1 unit. Then we have 5, 9, 13. Now, how many units do we have? 1, 2, 3, 4. They can be arranged around a circle in 3 factorial ways. Now, we are done with outer arrangement. Now, coming to inner arrangement. 2 and 14 can rearrange among themselves in how many ways? 2 ways. So, 3 factorial into 2 factorial. Now, this is nothing but 12. So, from these 4 factorial, 24 ways, we do not want these 12 ways. So the value of n1 is 12. Now coming to n2. N2 is equal to number of linear permutations of all the numbers from set A such that the same case, the adjacent numbers are relatively prime. Right. So if I have to arrange 2, 5, 9, 13 and 14, right, in a linear row, how many ways do we have? 5 factorial, 120 ways. Right. From this, I have to subtract the number of ways in which 2 and 14 are together. Right. So to do that, I'll be considering 2 and 14 to be a bundle. Right. Then we are left with 5, 9, 13. So how many units do we have? 1, 2, 3, 4. 4 units. So 4 factorial ways into. Now these two can rearrange among themselves in how many ways? 2 ways. 2. So 120 minus 24 into 2, 48. 120 minus 48. Right. So this should be 72. So the value of n2 is 72. Now what was asked? N2 minus n1. 72 minus 12. 60 should be the answer to this question. Now coming to the next question. If the letters of the word Parker are written down in all possible manner as they are in the dictionary, then the rank of the word Parker is. So we are given with the letters P, A, R, K, A, R. Now, if the words are formed using these letters, right, and if they are arranged in the alphabetical order, then what would be the position of the word P, R, K, A, R, right? So, what would be the first word? That would start with A. So, the first letter has to be A, right? Now let's find the number of words, right, that have A as the starting letter, right? So if we have A as the starting letter, you have 5 more words. So you'll be having 5 factorial by, now since we have 2 R's, right, there will be repetition of words. So in order to eliminate that repetition, we'll be having 2 factorial in the denominator. Now this 2 factorial is because of 2 R's here. So 5 factorial is 120, 120 by 2, 60. So there are 60 words with starting letter as A, right? Now after A, the next letter in the alphabetical order is K. Again, we will be having 5 factorial by. Now, once we have K as the first letter, right? Now A is free. Now K is fixed, right? So among the 5 letters, you have two R's and two A's. So you will be having 2 factorial into 2 factorial in the denominator. Now what is 5 factorial? 120, 120 by 4. You have 30 words with K being the first letter. Right. So we are done with A, we are done with K. Then next comes P. Right. So we are done with 90 words. When P is the first letter, right? Second letter should be A. Now we also want a PA, right? Okay. Then third letter, it would be A, right? In the alphabetical order, the third letter would be A. Now let's find the number of words having A as the third letter, right? Then what are the words that we are left with? Sorry, what are the letters that we are left with? R, R, and K, right? Now we need to arrange R, R, and K in these three places. That can be done in 3 factorial by 2 factorial, which is nothing but 3 ways, right? So there are 3 words having P as the first letter, A as the second letter, and A as the third letter, right? Then what? You'll be having P, A, and K. Now you are left with R, R, and A. Now similarly, you'll be having 3. Then what? PA, then comes R. Right. Now once you have R here, the fourth letter should be A according to the alphabetical order. Right. Then what are we left with? R and K. Now they will be arranged in 2 factorial, which is nothing but 2 ways. Right. So we are done with PAR. Now we are done with A. Next comes K. PAR, then K. Now if we have K here, next letter will be A and next letter will be R. Now you have 1, right? So we are asked to find this position. Okay. So let's see how many uh, words are there prior to Parker. You have 30 plus, sorry, 60 plus 30, 90, 90 plus 6, 96 plus 2, 98. So there are 98 words before Parker. So the position of Parker or the rank of Parker should be 99. Hence option B should be the answer to this question. Now coming to the last question. Two cards are drawn from a well shuffled deck of 52 cards. The probability that one is a red card and other is a queen is, right. So we have 26 red cards, out of which 2 are queens and we have 24 other cards, right? And in total, in the well shuffled deck of cards, in the full pack, you will be having 4 queens, out of which 2 are red, and you'll be having 2 black, right? Now we should be picking 2 cards in which one of that should be red and the other one should be queen, right? Now this could be either a red queen or a black queen, right? Now, if this is red queen, then you will be having 2 cases, right? Now, if this is a red queen, now this could be a queen or this could be any other card, right? Now, if we have a black queen here, now this can be any of those 26 red cards, right? Now, how many black queens do we have? 2, right? Now, from those 2, we need to select one. That could be done in 2C1 ways, right? If that's the case, this can be any of those 26 red cards. So 26 C1. Done. Now coming to this possibility where both are queens, right? So you have only how many ways? One way, right? This should be a queen and this should also be a queen, and both have to be red queens. You have one way, right? Then what? This should be a card other red card other than queen, and this should be a red queen. So 2C1 ways, this could be either a queen of hearts or queen of diamonds, right? Now this should be one among the 24 other cards, so that can be done in 24C1 ways, right? So the total number of ways would be 26C1 into 2C1 plus 24C1 into 2C1 plus you have one way when both the cards are red queens, right? By what are the total number of outcomes? So from 52 you are picking 2. So 52 C2. Now what is 26C1? 26 into 2. 52 plus 24 into 2. 48 plus 1 by 52 into 51 by 2. Now this is 26. Now 52 plus 48. 100, 100 plus 1. 101 by 26 into 51. 26 into 50 is 1300. 1300 plus 26. 1326. So 101 by 1326 should be the answer for this question. So option A.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.